So now we actually jump forward to a full sort of Estonian block in a way. And the thing is that we thought, besides the governments and sort of European Commission and so forth, let's have actually practitioners from academy, practitioners from private sector to come to the stage and really sort of show and practical things that they've been doing with data and some of expand our horizon with what could be the next things. So to start that sort of section off, the first one is Kristjan from University of Tartu, and I should warn you, he likes to throw in a few mathematical formulas here and there, so bear with him. All right, all yours.
Thank you. Hi. You're far too kind. Thank you very much. So my name is Kristjan Vassil. I'm a senior researcher at the University of Tartu and also the head of the Center of IT Impact Studies, a center that is formed actually last September and that deals with, we have kind of three focus areas. We take in large auto-generated data sets that are provided by public e-services in Estonia and try to add value to those data by estimating the fiscal impact of e-governance as such. But we also take a more active role, so it's not really academic kind of research per se. We also like to develop or prototype what we call next level or next generation e-services. So I'm going to be talking about how e-government accelerates innovation and why that is so important to our understanding of what really drives innovation. But before we go there, I thought, we have been talking about e-governance from early hours this morning and how great it is in Estonia and all of that. And also, as Sim said, I'd like to throw a few numbers in. So let's just zoom out first, and let's look at kind of the helicopter view of or on the Estonian e-governance, how large it is, what's its actual scope, the breadth, and so on. So, as you might know, the vast traffic of Estonian e-governance system, the entire ecosystem, goes through the data exchange layer, which is called the X-Road. And we have been lucky enough to establish a very nice collaboration with a state information system authority that is in charge, an institution that is in charge of running X-Road. And we got hands on the data. Since the first time when e-services were rendered, or the entire ecosystem kind of started off. And let me give you just a few anchoring points. So the graph on the left tells you the amount of queries, that is traffic, the amount of traffic within the entire ecosystem of Estonian e-government. And you see that from 2003, which we can call maybe 2002, but this is where we started really logging the data, the start of the e-governance, the birth of it. And it has grown to about 560 million in 2015. And on the right-hand side, you see the evolution of corresponding services, the amount of e-services that are provided to the public. It's more than 1,600 by now. The number of state institutions, there are also a few private institutions that render those e-services. And the nucleus of any government is the data repository upon which you can build actually these services. So that number has grown to about 200 as of now. And when we talk about the data repositories, we are not talking about tiny little data sets. We are talking about the population register type of registries. So these are large-scale registries, like vehicle registry and so on, that are really enabling in their nature. So how quick has that evolution or diffusion been? So in terms of queries, the actual traffic, the annual growth rate, the average annual growth rate has been about 45 million per year. In terms of services, about 123 services per year. The annual growth rate, the average annual growth rate for institutions is 73, and about 14 data repositories have joined X-Road on an annual basis since the birth of e-governance. So this is really the kind of anchoring points. This is the scope about which we are talking about. An important notice is that if we talk about queries, 560 million queries in 2015, this entails all of the queries, also machine to machine. So about 1/3 is estimated to be between actual humans. So there is a lot of automated or the mechanic interaction going on. So let's try to figure out what will happen in the next 3 years, using these data that we have. And for this exercise, well, Siim already warned you, I was told during my graduate studies not to bother audiences of this size with equations, but I never learned that anyway. So what we have here is exactly the same data set on queries. All of the queries within the ecosystem of Estonian e-government, but on a disaggregated format. They are now at the monthly level. So for each year you have 12 data points. And we want to kind of see how we could possibly explain or illustrate this growth rate, this nice little nonlinear growth rate. So you start off, and why this is important is because other countries want to estimate their potential growth for their respective e-governance. So this is why I bother you with it. So we start off with a simple linear equation where parameters A and B are estimated from the data, and X is basically the month, the number of months. And this is something that you all learned in high school, by the way. This is a linear growth model, the slope. X over Y, everybody should know it. But because it's nonlinear, we throw a second-order polynomial into it with a coefficient C estimated also from the data. I can give you the values for that, and you can compare it with your respective data from your countries. And the X is still the month. It's now just raised to the power of 2. And because it grows even more non-linearly, we introduce a fourth-order polynomial. And it turns out that this equation very neatly describes the actual data flock behind it. And what's even more exciting, and the very reason why we do these this is a simple exercise, but it just illustrates how eloquent this can be useful for forecasting the future. If you would extend the line to the time period that is not yet here, we can figure out the amount of queries, how much do they grow in 3 years' time. And you'll see that in 3 years from now, we, in all likelihood, will double the amount of queries within the ecosystem of Estonian e-government to about 1 billion. Now, I will eat a small size hat, which is not, which is edible in 3 years' time if that target will not be achieved. That's now on the record. How about e-services? We only talk about the queries. This is really the kind of the usage part, the people who actually use the e-government. But that only occurs when the services are rendered. Let's see how the services evolved over time. How has been this evolution of e-services diffused over time? And you see it's very linear. I'm not going to bother you with equations anymore, so you can relax on that term. It's a very linear function of time. Again, if we would extrapolate this, we would see that we would go from the current 1,600 services. I mean, just think about it. A country with a population of 1.3 million has about 1,600 e-services available in their ecosystem, and that number will grow to about 2,000 services in the next 3 years. I think these are really fascinating numbers. And also an important thing to look at is what is the rate at which institutions have joined X-Road and how the institutions have started seeing value in e-governance. And here's exactly the same numbers for the institutions, and you see that the data here is kind of a step function. So the institutions, and we've understood a bit of it now, the reasoning behind it, is that the institutions need to have incentives. They don't join e-governance structures by natural kind of will. They need incentives. And what Estonia has done is it has, through various state institutions, Ministry of Economic Affairs, State Information System Authority, and so on, they have incentivized, they have provided kind of programs for institutions to join. And again, we are currently at about 900 institutions that render their services online. The total amount of public e-services in Estonia is about at the range of 3,000, give or take. There are a few private sector companies here as well, but this is clearly a minority. And we are looking for, with the current growth trend, to about 1,100 institutions to join Estonian e-governance ecosystem. So just to recap very quickly, the helicopter view again. In terms of queries, in 3 years' time, we're looking for 1 billion. In terms of institutions, in terms of services, about 2,000, a bit more than that. In terms of institutions, about 1,100, and more than 200 data repositories will be part of the Estonian ecosystem. So whenever, and this goes to my Estonian friends in the audience, whenever somebody tells, this has happened now recently in Estonia, that the tiger has fallen asleep, that there isn't much innovation going on in the governance sector, that we are being lazy, then please show these numbers. I'm happy to share the slides. I mean, it's anything but sleeping. So now to the second point that I wanted to make in this presentation, the mechanism of innovation and how e-government and why e-government is so pivotal, so vital for driving innovation. I would like to give you an example, and I thank Hilda for already making an introduction to the road administration data from Norway. I usually start this part of the presentation with this graph, and when I ask people what do they see, I get all sorts of feedback regarding a feeling of terror and then anxiety and fear and everything that is related to a bad traffic accident, something that happened about 2 years ago in Jõelähtme, close to Tallinn, where a number of very unlikely road, traffic, and contextual conditions occurred simultaneously at one moment in time, in one geographical spot. My problem is, when I look at this picture, is that I see equation. I see an outcome that is discretely, periodically measured at the very lowest level of granularity by the Estonian Rescue Board. Additional to that, if you draw, this is a picture taken about a week ago when I was driving to Narva, one of the easternmost towns in Estonia, and it's not really the old windmill I wanted to take a picture on, but in front of that you see this little pole with some gadgets attached to this. This is our road administration that records parameters for certain road blocks or units on a real-time basis. Very similar system to what Hilda showed earlier. So we are living in a country at a time where we have road administration data at the very finest granularity, at the very, geographical granularity, real time. We have weather observations, the global weather, the local weather, and we have rescue board data on the accidents, the part of the equation that you want to explain the outcome when something happens. So you have road administration data, weather observation, and rescue board data. And we still only do the descriptive solutions on the basis of that we also saw in the Norwegian case, which is really important. It is important to tell people when and where, I don't know, there is a road construction going on, or when and where the wind blows at certain speed. But these data are unique to build predictive models. Now, let's kind of step back and figure out what's the difference between forecasting and prediction. Forecasting was something that I showed you earlier. What happens in the future given the trends or given the data that we have at hand. Prediction, when we talk about, at least I'd like to think of it as such, when we make predictions, we take in data from these kind of data sets that are not put together at the moment. They are kept separately. They're not cross-used. They reside in different silos, which is, of course, a big problem. But if you pool these data together, you can issue a real-time, you can build a model, a predictive model that estimates a likelihood score from 0 to 1 to every little roadblock for which you have observations. What is the chance that you will end up in a traffic accident before that actually happens? And this is where the value can come from, at least most of the value. The security part is really, really important, but the real added value, the transformational part, of disruptive part of the innovation comes from putting the data sets together that actually are not together at the moment and issuing those informed, controlled, multivariate, prediction-based models. This is, to the best of my understanding and the team that is behind our work, we think this is where the value really lies. And if you can build these models, then perhaps, and this is really a question with capital letters, perhaps you are able to predict the chance that there is a traffic accident before it actually occurs. And this is a universal approach that I think is one of the key points that I would like you to take away from this presentation, that we need real-time predictive models that can be applicable not only to traffic, but to any domain in which we collect data and in which we have data in separate silos. And that applies to economics, for monitoring the economic performance, monitoring and predicting, issuing predictions for companies on the likelihood of ending up going bankrupt, or a real-time economic monitoring that Tavi was telling you about this morning, predictive medicine, where you can predict the probability of developing type 2 diabetes before you develop the first symptoms. These data are all there, but they're not in one data set. They are all in different sets, and we need to figure out first how to put them together, and then we can figure out whether these models work or not. And there is no, well, maybe it's a bit of bragging, but it's just astonishing that we can do this in Estonia. There is no better place where we can experiment and try to figure out whether these models work or not. Thank you very much.
So there you have astonishing stuff, right? Okay, questions to Kristjan from anyone?
I think Dan is over there.
Oh, right. Dan, you're speaking soon.
Yes, I am. Sorry. I have this wonderful question about your beautiful graph. Shouldn't the amount of services actually go down as the time goes forward, as we optimize, we move towards sustainability?
I didn't get the beginning, sorry, can you?
Should the
number of services go down?
Should the number of services go down?
Right,
Yes.
so basically there can be duplication in and stuff like that, right?
See, the big problem for me is not really the services going up, because we are still at the early stages. What my problem is that when we try to cross these data with some kind of tangible measurement of characteristics that measure the thickness of a country, you know, how efficient a country is, like the amount of public employees, the public expenditure, it stays intact. So we are super effective in terms of e-governance, but the entire bureaucracy, sorry, it's not bureaucracy, administrative capacity and the expenses related to it stay exactly the same. And that, I think, I mean, there is clearly a latency to it and so on, but that is really the big problem, I think.
Okay. Anyone else? All right.
Hello, I'm Silja Kurma from PwC Legal, and I have also been researching the databases and the public e-services from the legal aspects, and I was very interested in your introduction, and I want to know, you said that e-Tiger is not asleep because the number of data repositories and services are growing, but I want to ask, are you going to assess also the impact of data quality in the databases and also the problems with the interoperability between the government institutions? Because for me it seems that e-Tiger is asleep because of these problems, that the data quality in the databases and the interoperability are huge problems, and maybe legal can also help, but that is only one part of the equation. So are you going to assess the other elements also? Thank you.
So we have a separate team at the University of Tartu assessing the legal aspects, the IT law people in there. My personal preference is to work with tiger puppies, the small things. I really believe that small things create innovation or disruption. So that's why we focus on the traffic area. And then when the legalese kind of step in, we solve them as we go. But if you take, you know, this grand approach that interoperability is a problem, then, you know, you don't get, somebody introduced the what was that, the personal data, the data protection fetish this morning, I think, this phrase. So this is something that I kind of want to avoid. So I prefer working on small kind of things, small projects, and then if the problems occur, we solve them as they occur.
But just to continue, I know that Innar wants to really come to the stage, but on that sort of question, and you mentioned yourself that, look, there's so many things we could be doing in terms of prediction, right? What is the number one thing holding you back? You and your team especially, if at all?
Time.
Okay.
But it's really nothing. The country has provided, I mean, we live in a I tell this...
And that's probably a resource issue, right?
It's a resource issue, but we have all the means to pursue these things. I'm going to approach Norwegians to develop this algorithm for not only Estonians that we are currently working on already, but also for the Norwegians. I mean, there is nothing that can really stop us at the moment, except that we have to find time to do that.
Cool. Thank you.
Thank you so much.